Okay, I think I got it. So we have A, B, and then we have C, and then we have E, and then we have D. Okay? And the figure is drawn like this. And we're told that this is 4, and this is 4, and the length of this is 6, and the length of this is 6. And so it says, are the triangles congruent? Okay, so let's list, So the question is, are these triangles congruent?
Yes.
Well, let's see. So in order to prove that the triangles are congruent, what do we need to prove? That their corresponding parts are congruent. So we need to prove that side lengths are the same length and that the angles are the same, based on the figure that they've given us. Well, So let's go through and list some things. If I say AB, the line segment AB, what is that congruent to?
D.
Yeah, so I guess what we have to prove, in order for these to, we would say that angle ABC should be congruent to triangle DEC, right? Oh, shoot, ran out of room there. DEC, right? Because C would correspond with C, right? Okay, so AB should correspond to DE, does it?
Yes.
Yeah, we know it does because we have these little hash marks, right? All right, so let's do the next one. BC should correspond to what? DC. We know it does because it tells us the length from D to C is 4 and the length from B to C is 4. Okay, cool. Let's do C to A, or we'll just say AC. Now, AC is 6, and that should correspond with
EC.
Yeah, EC. And we know that it does because they give us that the length is 6. So we've just proven that 3 of the sides are congruent, right? And they're corresponding sides, right? So that's important too. So now that we've proven the side lengths, let's go through and figure out what else is given. Well, we're also told that angle A is congruent to angle E, just based on the fact that I have this little arc and this single arc here. That's the way that we let the reader know that they're congruent. We know that angle B is also congruent to angle D. Oh, wait a minute, there's a flaw in our system here. So how did Mr. Adams mess up?
You should call it EDC.
It should be EDC, right? Now generally the convention is to write things in alphabetical order, but do you know why I just made that change?
So it lines up.
So everything lines up. So A corresponds to E, so B corresponds to D, and C of course corresponds to itself. Okay, so Mr. Adams made a little mistake there. I'm glad I caught it though. It doesn't affect the side lengths because you can measure A to C or C to A. You can measure B to C or C to D or D to C and C to B. Okay, so that was just one little mistake I made. Yes?
On the last one, does it say angle B is equal to?
Angle B, oh yeah, I kind of screwed that up. Angle B is congruent to angle D. Right? So now what's the last thing I have to prove? Well, now C is a weird thing. I can't call this C and call this C. So what I really have to do is I have to say angle BCA. Remember that the angle itself is contained in the middle. This is another way to write an angle. Is congruent to E is congruent to angle ECD. Now, how do I justify that? It's true, but there's one little way that we have to justify it. How do I know those two angles are congruent? Yes.
Hash marks in.
Well, I put the 3 hash marks there, but how do I justify that I put that there, the little arcs? Yes?
Since angle A and angle E are congruent, and angle B and angle D are congruent.
No, it's easier than that. Yes? It's not given to us. Yes? No. It's something. These are vertical angles. And vertical angles are congruent. Right? It's 2 lines. They're vertical angles. In other words, if I draw a straight line here, and I draw a straight line here, aren't those vertical angles? Does that make sense? And we know the vertical angles are congruent. Now they're congruent because of the linear pairing, right? We can have a linear pair from here to here. That's how we prove their congruence. And then we can also have a corresponding linear pair that goes from here to here. And because of the linear pair, we can prove the vertical angles are congruent, but at this stage, we just accept the vertical angles are congruent. Does that make sense? Any questions?